Thank you for joining us. I'm Prateek Sharma, Senior Solutions Architect with Strategic Accounts team at AWS. I work closely with Netflix security team, and today I'm thrilled to reintroduce Mike Grima to you. Mike is a Senior Cloud Security Engineer at Netflix, and this is the second part of his talk, where he will explore how to get visibility on what's happening to your S3 buckets and the steps one can take to block public access on all S3 buckets within your organization. Thank you. Over to Mike.
Hi, everyone. This is Mike Grima, Senior Cloud Security Engineer at Netflix, and welcome back to part 2 of our discussion on closing the lid on public S3 buckets, preventing S3 bucket exposure. If you have not seen part 1 of this discussion, please go back, watch part 1, and then return to this video. So in this discussion, we're going to explore our BPA journey in much greater detail. We're going to show you how you can effectively locate publicly accessible data in S3. And we're also going to show you how to design tooling to implement BPA at scale. So let's continue. At the end of part 1, we discussed account inventory and why an account inventory is a critical part for making an infrastructure-wide automation capability. Before we move forward, unfortunately, we are not open sourcing anything at this time. We would like to open source the tooling that we're going to discuss in this talk, but we need some time in order to prepare to do so. And we may or may not do that. If we do, you'll find out. So in the meantime, what we will do is we will demonstrate the patterns that you can follow to build this type of tooling yourself. So for infrastructure automation, you're going to want something that can run tasks across your entire infrastructure at scale. And this goes well beyond block public access. If you have a large cloud infrastructure or even a moderately sized cloud infrastructure, the last thing you want to do is log into the console to each individual account and hit buttons all the time. So you're going to want something that can operate across your entire infrastructure and ensure that a security policy is set, or even if you need resources that are resident in given accounts, you can write tooling to place it there and enforce that things are configured properly. There are a variety of options that you can pick from. You can either build your own, which is what our team at Netflix did a little while ago, or now, in fact, there's a feature from AWS, the AWS Systems Manager Automation Documents capability, which will allow you to write scripts and target individual AWS accounts. So this is actually a really great feature that you can make use of to implement infrastructure automation. We developed a tool a little while ago called Honeybee. The way it works is it makes use of lots and lots of lambdas. And we find that Lambda scales very well for our use case. The way Honeybee works is that we define worker bees that then enforce a desired infrastructure state via a template that we design. We have a bunch of workers. To name a few, we have a worker that enables S3 server access logs all over our infrastructure and on every S3 bucket. We enable this with Honeybee, and that is relevant to this talk. We also have a worker that does IAM role and manage policy templates across our whole infrastructure, which is very useful for us. And lastly, but certainly not least, we have a worker that enables S3 block public access all over our infrastructure as well. From a 1,000-foot view, the way our architecture works is that we have a component called the queen bee. And the queen bee invokes worker bees through SQS queues. Worker bees are registered with the queen bee and define its invocation parameters. For example, we have some worker bees that operate on a cron-like schedule that are executed through Amazon EventBridge. We can execute them through SNS topics or even on S3 object uploads, like for instance, if a worker bee template is updated and goes into S3, that can then invoke the workers to go out and do some work. How the queen bee works is that it will task a worker for a given account or account region pair, depending on how that worker is configured. There are different types of jobs, and each job may be sharded on an account or an account region. And so the way that the queen bee does this is that it queries the account indexer that we mentioned in part 1, and it then looks at the worker bee template, and it generates a template per account. And with this, it then tasks a given worker bee for that given account or region pair. Once the worker bee runs, and there's thousands of worker bees that run at any given time, the worker bee is able to assume to an IAM role in the target AWS account, and then from there, the worker bee takes the template and it implements it. So this is a way that we can implement config as code, but for our entire infrastructure at a time. And because this is a tool that has wide-reaching capabilities and it makes security-sensitive decisions, we have Honeybee reside in a security-sensitive account with limited access. So you don't want to keep this tool with all your other stuff, because if this gets compromised, that's your whole infrastructure, right? So definitely place security-sensitive tools like this in a special limited access account. The next stage of our journey is to enable bucket logging. Now you may be asking me, well, Mike, why do we care about bucket logs if we're just trying to turn on block public access? The reason why is because there's a number of different approaches that you can take to this problem. You could just turn it on everywhere. You may have a use case where there's no legitimate use case for a public S3 bucket at your company, and if there is one, it shouldn't exist, and it's okay if it breaks. And if that's the case, do it, right? Like, if that works for you, do whatever works for you, right? So if just turning it on everywhere, no questions asked, is the right solution for you, go ahead and do that. At Netflix, however, we have a lot of public buckets that are intentionally supposed to be public. And so if I went ahead and just turned this on without doing my homework, I would get a lot of trouble. I'd make a lot of people angry, and that wouldn't go well for me. So I want to avoid outages, and I want to gain some knowledge as to how our infrastructure works. And so another way to do that is I could take a look at every single bucket, and I can take a look at every single object and assess their permissions to see if they're public. And then from there, I can then track down and see if that's supposed to be the case. This may work well for you if you have a small number of buckets or not a lot of objects in S3. However, we have a lot of objects in S3 and a lot of S3 buckets all over the place. And so at scale, this becomes very annoying. And when you have billions of objects, this can become rather untenable. So is there another way? Well, it turns out there is. What if I could query an access log to determine if in the last 6 months we had successful publicly downloaded objects? So if someone downloaded an object successfully without authentication, then that would imply that this object was downloaded publicly. So this is a great pattern because you can not only get a very accurate usage pattern, but this will also allow me to track the users and the applications that are placing the objects into the buckets, so I can actually investigate to see if that's supposed to be the case. So with bucket logging, you get a very accurate set of details on who or what is accessing S3. And this is not just for security use cases. This goes well beyond security use cases. In fact, in our case, we have lots of users that query our S3 access logs all the time because they're debugging some issue with their application. And if they don't understand why they're seeing error messages, they could go to the logs and get that context, which has been tremendously valuable for them. It's also tremendously valuable for security because we can actually do investigations and see what's going on. There are two primary solutions that you can pick. One is the S3 server access log capability, which has been around for a very long time with S3. And in fact, this is the one that we're using at Netflix, and we enable this capability through Honeybee. Since then, however, since we developed this, Amazon has beefed up CloudTrail, where now CloudTrail can track object operations as well. So this is another very good option that you can make use of too. Lastly, you're going to need something that can analyze these logs. You're going to need some big data tooling. Having all these logs available but no effective means of searching through them is not very useful for you. And this is going to be very hand-wavy. But yeah, just get some big data tooling. Everything is solved, right? I get that that's very hand-wavy. And unfortunately, I don't have a better answer than that. If you have an organization in your business that can process big data type use cases, then absolutely seek their assistance. If you don't, then this is where something like Amazon Athena may be a good solution for you. And Amazon actually has a number of documentation around Athena, around S3 access logs, as well as CloudTrail. So Athena could be a very good solution for you. Internally at Netflix, we utilize Presto and Spark, and there may also be some third-party SaaS products that can assist you as well. I know that's hand wavy, but unfortunately, I can't think of a better thing other than get some big data tooling. So once you have big data tooling and you're able to query logs for details, then you go into the investigations and analysis phase. And this is where you're going to analyze your logs to find publicly accessible stuff. So S3 Server Access Logs, which is what we're using at Netflix, has all of the details that we need. And I have linked on this slide the link to Amazon S3's Server Access Logs format. So you can see what the fields are that are logged. And in our case, we only care about two things. We care about requests that are successful and are unauthenticated. If you successfully, without authentication, grabbed an object out of S3, that object is public. So that's what we care about. So if we look at the S3 Server Access Logs, if we see what fields are available, this field sticks out. That's the requester field. If a request is unauthenticated, the requester field will have a hyphen for it. So there's no AWS principal that grabbed this. This is unauthenticated. So we want to query for requester fields that are set to a hyphen. And we also want to query for a positive HTTP status, which is also logged in the S3 access logs, because we want successful unauthenticated requests. And so here's a sample Presto query that would basically give us the S3 bucket and the count of requests that were unauthenticated and successful to this bucket. You can also adjust this query to get the specific objects in question that were publicly downloaded. But in this case, we just want to get a list of the buckets. So this seemed easy, right? I'm like, oh, this is great. This is going to be awesome. So I ran this query, and I was terrified by the results. The results were really scary, and I saw lots of buckets in there that should absolutely not be in there. And I immediately went and I verified the permissions of that bucket, and I verified the permissions of those objects that it said. And I'm like, no, these are private. And I confirmed like 5 times over, this stuff is private. This is not publicly accessible. So why is it showing up in the logs? Why so many false positives? So I looked in the documentation and this note came up. And it states that any field can be set to a hyphen to indicate that the data was unknown or unavailable. So why would that happen? And then in the logs it says this too. It says that there's a best effort server delivery. And so basically S3 will try its best to deliver you complete logs, but sometimes it's not able to. So if the data is not fully complete when it ships the logs to you, you will get that hyphen for those fields. Now, this is unfortunate. And the thing to note is this doesn't happen that often. However, in our case, because we have so much volume of data in S3, this happens enough to be in our logs. And so because of that, even if it's a small, minute percentage, it will still show up in this log query. So I need a way to account for this and to work around it. And so I went back to the logs and I said, okay, is there another field that I can query that can give me exactly what I need? And it turns out there is. There's another field called authentication type. And it also turns out that if there is an unauthenticated request, the authentication type will also have a hyphen. So I thought, okay, what's the likelihood that both the requester field and the authentication type field would be missing? So I updated the query to also include the authentication type, set to a hyphen. And when I ran this, I got results that were massively better, like way better. Massively better. But I still saw a couple of false positives linger about. And those false positives are related to S3 signed URLs. S3 signed URLs, I'm not going to go into too much detail. You can refer to the AWS documentation, but S3 signed URLs are legitimate authenticated S3 requests. So I don't want to have those in my logs. And in which case, you can actually filter them out. If you look at the request URI field, you will see X AMZ security token in the string. So I updated my query now to put a not like anything that has the X AMZ security token inside of it. And so once I made this query and I queried those results, I got back perfect results, exactly what I needed, which was just purely public data and nothing out of the ordinary. This is like, okay, this is exactly what I want. Once you have all this data, now you can do the hard part, which is tracking down users and taking a look at your data, seeing, okay, which of these buckets need to be public, which ones don't. And you're going to reach out to your users, you're going to ask them some questions to figure that out. And you're going to document this data. And if there's users that need to move data, you'll work with them to move data. But basically, this stage is just documenting so that when you're ready to turn things on, you don't break the buckets, so you ignore the buckets that are supposed to be public. Cool. So now you did your investigation and your analysis, and now the next step is you need to turn it all on. So, like I said, we're not open sourcing anything yet, so we're just going to provide some guidelines. And what we would recommend is that you rely on a template type automation structure, where you'd want to enable block public access by default, except for the buckets that are intentionally public. And you'd want to have that codified in a template, so you have a one-stop shop, one authoritative source of truth that tells you these are the buckets that are public, anyone that's not in this list is intentionally private, and it's enforced by your automation. And you can also specify per AWS account configuration override. So if you have one account that has different use cases than another, you can do that here as well, and this is your source of truth for that. Here's an example template that looks very similar to what we have internally. In this template, we have a include accounts, which basically we set asterisk for. So we want every single account in our infrastructure to have this automation applied. We can specify which regions this automation applies to. So if there's a region we want to exclude for whatever reason, or we're turning this on piecemeal, we can do that. We have a section where we specify what our public buckets are. So this is a template with an authoritative list of all of our public buckets. And we also have wildcard support. And that's important because this allows us to enforce a naming convention for public buckets, where if there's a use case where we have a team that needs to mint numerous intentionally public buckets, that's fine. But we don't want our automation to be impacting them. So this way we can say anything that is wildcarded and has this naming convention is public, and that's fine. And we work with those teams to make sure that that's okay. So anything that's not in that gets turned on by default. Anything that is in that, we don't touch, and that's fine. We also have the ability of specifying a per bucket configuration for overriding a default set of block public access settings. So for example, we have several buckets that cannot have all 4 settings enabled. And so for that, we specify the specific name of the S3 bucket, and we specify the specific block public access capabilities that are enabled for that bucket. And so this gives us the flexibility to do that. We also, lastly, have accounts listed that we can enable this on for the entire account as well. So we enable it for the account in this case, and also on every bucket in there. So we really cover our bases. And one thing you might want to do is you might want to inverse that logic, where by default you turn it on for the account and you instead exclude specific accounts where you want to allow public buckets to be in there. But at the end of the day, you want to have a template that has this codified, so you can just go to that and point to it and say, this is how it works. And that's nice because you can have a consistently set of rules for your entire infrastructure, so it's easy to comprehend and explain and figure out what's going on. You want to provide flexibility. You may have use cases that can't fit all of the bucket security stuff that you want, right? And so you want to be able to be flexible to that, but still be able to accommodate everything. So there's nothing wrong with having flexibility. In fact, it's encouraged. Another thing that we do in our automation is we make use of tagging heavily. In fact, we're leaning into tagging in a very big way at Netflix. And One of the big things that our automation does is whenever it encounters a bucket, when it analyzes it, we will tag that bucket, whether it's public or not, based on what is configured in that template. So buckets that are public, we will tag as public. Buckets that are not, we tag as private. And that's very useful because we have a lot of downstream automation that looks at resource configuration. And based on that resource configuration, those tags come through. And so those tags provide very useful context about that resource. So we can say this is a public bucket, and we know that because it's tagged as such, or vice versa. So that's very useful. You also want to make sure that you have proper metrics and alerting on failures. You have automation that's touching your entire infrastructure. So does it work? How do you know it works? Well, if there's an alert on a failure or you're collecting metrics, you can determine whether things are working properly or not based on that. So definitely make sure your automation has some metrics and alerting on failures. What I would also highly recommend is to make use of AWS config as much as possible. And there's a very good reason for that. When you're making infrastructure automation like this, in order for it to function properly, it needs to be able to describe all your assets and all of your stuff, right? And when you're describing all these things, you're making lots of API calls in short succession. AWS will rate limit you if you make too many API calls too quickly. And if you get rate limited, that not only impacts your automation's ability to do work, but it will also impact all of the tenants in your environment as well. So if you have an AWS account with other automations that are running, that are making AWS API calls, if you get rate limited, you will rate limit them also. So you could potentially do a denial of service on yourself by doing that. So that's something you do not want to do. You don't want to be a noisy neighbor. So the way that you do this is you rely on something like config, which is a cache of your resource configuration. So you query AWS config to get all of your resource details, and then you're not actually making API calls against the rest of your infrastructure that could impact your tenants, your co-tenants. And so this will allow you to do what you got to do without being impactful towards other tenants in your environment. So you won't denial of service yourself, which is important. And lastly, but certainly not least, blanket your automation in tests. This thing is going to touch lots of resources. You want to make sure that it does exactly what you say it does. And if you are a Python developer like I am, you'll probably make use of the Bodo library for AWS. And there is a library called Modo, which is a mocking library for Bodo. I actually contribute a lot of code to Modo. It's a really great library. Yours truly actually wrote to the AWS config and the S3 block public access features. So you are very welcome. And I was very thorough in its implementation. So I know for a fact that, that if you make unit tests against it, it will work properly. So there's absolutely no excuses for having poor test coverage in your code. Please take the time to write unit tests. You will very much not regret that. So in conclusion, this is a journey that is worth traveling. You will learn a lot about your infrastructure, and I encourage you to do so because it's revealing as to how people are using S3 throughout your organization. So logging is important. It goes well beyond just block public access. And you really want to take the time and invest in automation for your entire infrastructure. It will solve so many security problems as well as other operational use cases that you may not think are important until you get it done and you're like, wow, I'm so glad I did that. So with all that, you are now equipped to start closing all of those lids. No excuses. So thank you so much for attending this talk and both talks. So I really appreciate that. And send me a message if you have any questions. And of course, don't forget to complete the session survey. Thank you.